part part five of building your own Hopper single board computer, 6502 computer. And it's time to put the thing together, to assemble it. Now, we'll go through a few things before I even start. And one of them is I'm not going to make a video of me, if you actually watching me solder, for a number of reasons. First is I can do it at my leisure rather than being conscious of being on a video. And the other one is my setup is not exactly geared for making videos. The camera's in the way, the microphone's in the way. And the biggest problem with it is that I have a fume extractor there for my soldering iron. And yeah, and I'll show you. Like, there you go, microphone in the way, camera in the way, fume extractor. So it's much easier just to do like snapshots as I go through the process. On the subject of the fume extractor, if you're using leaded solder and you're not using a fume extractor, you might as well be smoking leaded paint. Your future self will not like you. And even if you're using lead-free solder, it's still a good idea. They're good little devices to own. Failing that, do it in a ventilated spot or with a wide open window right up above your desk. That would work too. Or a fan blowing through, so just so that you don't inhale the fumes from your soldering iron. Okay, let's talk about a little bit of circuit board assembly 101. When you're assembling a circuit board, you want to put the lowest profile parts on first. And the reason is because we put the parts through and we bend the pins behind here, and we want to sort of sit there. And then when you put like sockets on, you want to sit on the socket. You want the board to sit on the socket while you're soldering the back. So if you put like, a high profile part on first, it's going to be a real pain. You'll only be able to put the other ones on one by one. Also, if you see between the big chips, there's some resistors there and jumpers. It's harder to put these in once the socket's already there. It's easier to put chip components like that in when there's nothing around them. So we'll first put the small low-profile components on. Another thing we're going to do first is we're going to test, early on, we're going to test that our power supply is doing what we want it to do. So the first thing we're going to do is we're going to just put on 3 components, like the 470 ohm resistor and the power LED and whichever breakout you need for the FTD device that you have. And once we've done that, we're going to test the power. And we're going to plug it not into a power supply, but not into a computer, but into a USB power supply, just to check that we've got 5 volts coming out where it should, not 3.3 volts. And the pinouts for these different devices are all different, so it's important to get it right. And then we're going to put on all the low profile components in the next step. Another thing, and the low profile components include things like the diodes, this supervisor chip, 5-volt supervisor chip, and the diodes. Now, interesting thing about the diodes is they have nice fat leads, and I'll chop one of these leads to use it as a jumper, because I'm building for the 65CO2S right now, that chip. You could have the MOS 6502 as well. If you use the MOS 6502, you need that jumper. If you use the 6502S, you need that jumper. So we only need one jumper on this board. And I'm going to use one of the leads from one of the diodes as the jumper. Okay. Let me get on with that. I'll insert all the components, solder them all in, and chop off all their leads. Another thing to be aware of is when you clip the little metal bits off and they fall on your desk, pick them up and get them out the way. Because the last thing you want to do is put your finished circuit board down on little bits of metal and then plug the power in. So it is good to be sort of tidy with those little metal bits, little metal scraps. Okay, I'm going to get on with soldering on all the low profile components, and then we'll check the power. So that'll be done. That'll in the video be in a couple of seconds from now. Okay, I admit it, I got a bit carried away. I was supposed to only install these breakout pins, this LED, and this 470 ohm resistor. But I also figured it'd be handy to put this breakout over here because it's ground and 5 volts, so it'd be a good place to test the power. But I also went ahead and put in all the low profile parts, sort of got carried away. So we've got our power supply set up, our FTDI input, and I've done just the one that's for this board. So let's see if we've got any power, shall we? Oh yes, we've got a red light. Okay, that's always a good sign, red light. Little red LED saying the power's on. And now I've connected my voltmeter to these two, to that breakout there, and we'll switch it to volts. And yeah, that's great, good demo. I've got -5 volts. Let's see if I can see that, get that on the camera. You can't really see, there's a negative sign in front of the 5 volts there. Yeah, it's pretty useless. But it's because I got I've got the leads the wrong way around. I've got the black one on the red lead and the red one on the black lead. But anyway, I've got 5 volts. So happy that I've got 5 volts, not 3.3 volts. All good. And then another little sneaky trick I like to use is I've got one of these really cool little pens. It's like a paint pen. And I'll go find the 5 volts, the 5 volt pin here, and I'll paint it red like that. And I can actually paint onto this thing as well, why not? And let that dry. So now for the future, when I plug it in, I've got that little red marker there that'll help me figure out that that's the way it plugs in. Okay, so we've checked our voltage, we've checked our power. We could probe around the board because if you go and look at the schematic, you can see where the positive and ground pins on all these chips, and you can poke around and see if the voltage is all right. Obviously, I did that when I first built the PCB to check that the design was correct. But we're not going to bother with that here. So we've got all our low profile parts on, plus one slightly higher profile part, which is going to be a little bit annoying, but I wanted to put it on there so that I could use it to test the voltage easily, like easily probe the voltage. Right, and again, I mentioned my jumper. So this is the jumper that I put on. The jumper I made it by using one of the leads from one of the diodes. Orientation of the diodes, you can see where the white end is, and that's on the silkscreen of the board. There's a pattern for that too. Another tip for this board is, of all the most finicky thing to solder, the most finicky thing to insert is the switches. The most finicky thing to solder is the supervisor chip, this little thing that looks like a transistor, but it's not really a transistor. And you can see why, because let's unplug the power. Those pins are really close together in there, those 3 little pins. So again, a good use for your multimeter. Once you've soldered these, you can check with magnifying glass that there's no bridging between them. But I then checked with the multimeter to make sure that there was no continuity between those pins. So it's worth checking that one. The rest of it's pretty straightforward and nicely spaced, but those 3 pins are pretty close to each other. Okay, next step. What do we do next? We put on all the sockets, but we won't put on the high profile ZIF socket yet because it's a little bit too much in your face. So, a little bit too high. So first we put on all the sockets of all the socketed components. I recommended in the other videos that you might want to socket your CAN oscillators. On this board, I know I'm only going to run it at the default speeds, so I'm going to not socket my CAN oscillators on this board. I'm just going to put them straight on the board. CAN oscillators are relatively easy to desolder compared to things with dozens of pins. And I mean, if worse comes to worse, you can cut the CAN oscillator in half with a pair of clippers and then desolder 2 pins at a time. But you can probably desolder 4 pins to get a CAN oscillator off without destroying it as well. Obviously there's people who do this a lot, who are a lot better at it than average, and they can easily do that. But for people who are not used to doing a lot of soldering, it's hard to take component off the board when it has a lot of pins, and that's why we socket. We definitely want to socket the GEL so that you can reprogram it to change the memory layout, and of course we're going to socket the EEPROM. And then previously I've mentioned you should socket all the retro chips because this board will have a lifespan, and I'm hoping that the retro chips will live longer than the board and get recycled by somebody else into something else. So socket all the retro chips. Okay, moving on. I'm putting the sockets on. These are fun to solder. It goes pretty quickly. Okay, we've got all our sockets in. So there they are. Sockets all soldered in. Lots of solder on the back. And the remaining components are these guys. So they're the sort of higher profile components. Now, if you don't have these cut to width already, what you do is you clip them, with parasite cutters, and you're going to clip them. You clip it on the next pin that you're not going to use. So if you want one 4 wide, you'll be clipping it at the 5th pin, and you lose that pin. But if you clip it any closer to the 4th pin, you'll lose the 4th pin too. So you clip it on the next pin across from the length that you want, and then you can sand down the edges and make it look pretty. Okay, what am I going to do next? I said I wasn't going to, socket my CAN oscillators, so I'll put the CAN oscillators in, and then I'll put the remaining components in with the higher profile ones, which includes the ZIF sockets and the electrolytic capacitor, and the remaining headers for the parallel port. Let's do that. Okay, CAN oscillators are done. There they are, one there and one on the other side. Now, on the silkscreen, there's 2 hints to how do you position your CAN oscillator. You'll notice that there's one sharp corner on the CAN oscillator, that bottom left corner. You can see it there in the other one. So the CAN oscillators have 3 round corners and 1 sharp corner. And if you've got a half CAN, it goes on this side inside the silk. If you've got a full CAN, it fills the whole area. So that's how you orient your CAN oscillators, and obviously the frequencies are shown there. All right, moving on, I'll put on the remaining parts. Okay, and that's it. I soldered all the bits in that need to be soldered. All the soldering of the board's done. Now, at this point, it makes sense to go and clean the back of the board, clean the extra flux off. And you've got everything you need to do this in the kitchen, like just a little sponge and some detergent. Make sure you don't get any water in the ZIF socket. In fact, try to keep it as dry as possible. Just do it with a damp sponge, because you won't have the patience to wait for it to dry before you start plugging things in. So just be careful not to make it wet, too wet, when you clean off the flux. Okay, and now we get to put the chips in. So in terms of getting this board up and running, the next part in this video is going to be, and I ground myself before I touch these chips, even though it's kind of hard to kill them with static. And now these pin benders come into their own, so we'll straighten up the pins a bit of our 6502. And then, the next thing we're going to do is we're going to do a blink test. We're going to test with the built-in LED, this built-in LED, with just the EEPROM, so without RAM, and see if that works. Anyway, let's see if I've got all those lined up. Yeah, I do. Important to see that the pins are all lined up before you push it in, and then seat it like that. And again, just make sure you didn't bend any pins over. So, eyeball down the edge of the pins just to make sure you didn't bend any, and do that on the other one as well. And we look good. So we move on to the 6532. 6532, it says 65C32 on the board, but they don't all have the same labeling, and they're pretty much all the same chip, so don't worry about it. This one here says it's a, what does it say, 6532, it's R6532, there we go. So all my pins are lined up in the holes, are they? Yeah, is it looking good? No, these ones aren't lined up. Let's put those on. Bit fiddly. my pins in. Yeah, I think they're still splayed a little wide, so I'm going to squeeze them a little bit more in my pin straightener. Let's try again. There we go. It felt like they were lining up better. Yeah. Again, making sure I've got them all lined up before I actually put any pressure on to push it down into the socket. There we go. And we're in the socket and eyeballing the pins down both edges. They look good. Okay, what else do we need for our test? Oh, yes, we need our gel. So we're going to need our glue logic chip to go in here, like that. But we're first going to need to program it. So let's move on to the next video, which shows us how to program our gel, and then this CPLD, and then we'll pop that in, and then we'll start doing some testing with this board. That's all we need in the board to start testing. Thanks for watching, and after the next video, you'll know how to program one of these.